Hi guys, this is Dr. G here, and in this particular video we are going to talk about organometallic coupling reactions, and especially in this video we are going to talk about the synthesis of Gilman reagent and how you can use Gilman reagent in coupling reactions. Okay, so in this particular video the first thing that we are going to talk about is the synthesis of Gilman reagent. So the synthesis of Gilman reagent is somewhat similar to the preparation of Grignard reagent. Okay, so in Grignard reagent we used things like alkyl halides and treated it with magnesium, if you remember. So if you don't remember, I recommend that you guys go and watch the video on the synthesis of Grignard reagents. Okay, so the difference here is that during the synthesis of Gilman reagents, this is a two-step process. Okay, so this formation of Gilman reagent is a two-step process. In the first step, what you do is that you react an alkyl halide with lithium. Okay, so you will react an alkyl halide with lithium in order to obtain an alkyl lithium compound. So that will be your first step. Okay, and the alkyl lithium compound that you obtained from the previous step will be reacted with copper iodide. That will be the second step. So in the first step you will react alkyl halide with lithium and you will obtain an alkyl lithium reagent, and then the alkyl lithium reagent that you got will be reacted with copper iodide to obtain the Gilman reagent. So basically Gilman reagent is a lithium diorganocopper compound. So you basically have a lithium cation and a copper anion, and this copper anion also have two R groups or organic groups. Okay, it has two R groups, so that is why we call it diorganocopper. Okay, so that reagent right there is known as a Gilman reagent. Okay, is known as a Gilman reagent. I'm sorry about that. Is known as a Gilman reagent. Okay, so this particular Gilman reagent can undergo coupling reactions, or in other words, the R groups that you have, or the organic group that you have in the Gilman reagent, can be easily coupled to other organohalides. So in this particular slide, I am going to talk about three different reactions that you can conduct using Gilman reagent. Okay, so these are the three reagents. So let's first look at the first reaction. Actually, you may have seen a similar coupling reaction with Grignard. Okay, so in here what we do is we take our the Gilman reagent, which is the lithium diorganocopper reagent, and one of the organic groups from the Gilman reagent will be coupled to the R group of the alkyl halide. So you are reacting a Gilman with an alkyl halide, and the organic group from Gilman will be coupled with the R group of the alkyl halide, giving you an alkane. The product will be an alkane. Okay, so that is the first reaction, and we have seen a very similar reaction with Grignard reagent reacting with alkyl halides. But the next couple of reactions are actually much more unique to Gilman reagents. So in the second reaction, what we have is a vinyl halide. Okay, in here we have a vinyl halide, which means you have a carbon-carbon double bond attached to a halogen. In here it is an iodine. Okay, so vinyl halides can also undergo a coupling reaction, with a Gilman. Okay, so an R group from the Gilman will be coupled to the R group or the organo group from the vinyl halide compound. Okay, vinyl halide compound. That is actually a very unique reaction. And also in the third reaction, okay, halobenzenes. Okay, halobenzenes can be coupled to Gilman reagents. Halobenzenes can be coupled to Gilman reagents. So basically, the R group or the benzene from the halobenzene will be coupled to an R group from the Gilman reagent. So in here, the benzene is coupled to a CH3 group, giving you a toluene. Okay, so these three reactions are actually very unique to Gilman reagents. So I hope that you guys will put these three reagents in or reactions in your reaction book, and these will be tested in your incoming midterm. Okay, so with that, I'm going to conclude this video. If you have any questions, you guys just let me know. Okay, have a good one.